It's time to chill out and get ready for a mediocre Q&A live stream. If you're old enough, grab yourself your favorite adult beverage, and if you're not, stick with apple juice. Put your feet up and relax. If you have any questions, feel free to ask them in the chat. And now let's cue up the intro music. Hello. Had to turn my microphone on. I almost forgot there. I almost pulled a Zach, but I didn't. So that was the important part, right? Nah, I'm just messing with you, Zach. Hopefully you guys are doing well. I see everybody in the chat. What's up, guys? I know a bunch of people are saying, hey, I don't know why that dang Nightbot, I can't figure it out. It keeps posting the movie quotes way too early. But I'd be kind of curious. Nightbot, Nathaniel, is giving movie quotes. I always put a movie quote in the chat for people to guess, to see if they can figure out what movie it's from. So let's see. This is a pretty obscure movie, and I'm sure you guys could Google it, but let's see if anybody guesses it. So, yeah, hey everybody. I see got quite a few people in here already, so cool. Got a couple things as usual want to talk about. First thing I want to start off with, and I'll definitely address the stuff in the chat too, okay? As usual, guys, please put your questions from the chat in caps lock. If I fail to answer your question, throw it in there again, okay? I'm not ignoring your question. I usually will tell you, hey, you know what, I can't answer that one right now if it's something that I can't answer. So if I haven't acknowledged it, go ahead and keep putting it in there, okay? And I'll definitely try to get to it. So, what I have... Sorry, I lost my train of thought there. Anyways, don't know if you guys happened to catch it, but I was on the Overtime show. We got a bunch of the Overtime guys that are always in this chat right now. Joe, HVACR North, is in here. They do that show Friday nights. Joe, refresh my memory, or Justin, what time it is. It's either 5 or 6 p.m. on Friday nights on Zach's channel. For some reason, that's escaping my mind right now. But you guys definitely should check that out. I was on there this last Friday and had a little bit too much to drink, but it's all good, you know? So what I wanted to start off talking about, really simple phrase. I use it all the time, guys. Big picture diagnosis, okay? I've probably drilled it down your guys' throats. You guys are probably sick of it. But I'm telling you, big picture diagnosis is the way to go about it. It definitely helps to make sure that we diagnose these problems and we diagnose them correctly, okay? When we are working on our equipment, it's so imperative, okay? I've given so many examples of taking a step back and looking at the big picture, and I'm going to give you guys a little bit of an example right now, okay? We get a service call on a walk-in cooler, and this is going to be an easy one. I've had this topic a lot lately, but I'm just going to kind of give you guys some information, okay? So we get a service call on a walk-in cooler. By the time we get out there, you know, the unit's down to temp. It's working fine, okay? And I know some of you are already guessing where I'm going, but I'm just trying to elaborate this point, okay? So we get out there, the walk-in box is working fine. The manager swears up and down, it wasn't working this morning, okay? We don't just walk away from that problem. Big picture diagnosis. The first thing we should be doing when we walk in the door of that restaurant or building or whatever is asking questions. Asking those questions, being thorough, okay, it really helps you. And if it makes it easier, the moment I walk in the door, I go find the manager, I shake their hands, bump their fist, whatever, say hey, ask them how they're doing, ask them how business is going. And then I ask them about the problem. And then when they tell me about the problem, I say, hey, this is something I always ask. Is there a certain time of day that this happens? Does it happen often? Is this time, you know? And they will give you a lot of information if you just ask. All that information is going to lead to the big picture diagnosis, okay? Same thing. When you get up to the box, don't just walk away from it because it's working properly. This can go for almost anything, okay? Just because it was working when you were there, you don't stop, okay? You keep powering through it, and you start rationalizing in your head. You start listening to what the manager said. In my situation, the example I'm giving right now, the manager told me, hey, you know what? The box was making this weird sound from the evaporator coil. It was hissing at me. And when, you know, but he goes, I really didn't think too much of it. You know, but all that information goes into my head and helps me to diagnose the problem. So the problem that I'm describing is a low refrigerant charge in the wintertime, okay, on a walk-in cooler. And the head pressure control valve, yeah, I'm sorry if the mic's cutting out. I don't know what we'll address that right now. So the head pressure control valve is trying to flood the condenser when there's not enough refrigerant in the system. And in that situation, that problem will really only show itself when it's really cold outside. When it's warm outside, the box will work. So big picture diagnosis, asking all the questions, thinking about everything and going through it, then you can diagnose those kind of issues. Okay, so it's so important to ask questions and be thorough with everything. Yeah, I don't know why the mic was distorted, guys. That's a little weird, but yeah, I'm going to fix it right now. Hold on. Let me see this. How about that? No, so that's a little bit still distorted. Let me go back down a little bit more. That should be a little bit better. Move this away a little bit. How about that? That should be getting better. For some reason, I'm still showing some... yeah, sorry about that, guys. Yeah, let me see here. Hopefully that's getting better. Is that getting a little bit better for you guys? Hopefully. Hopefully that'll be getting better there, because I'm noticing that it's doing a little bit better now. So I apologize about that. All right, there we go. Let's see if this gets any better there. Okay, cool. Right on. Sorry about that, guys. Yeah, I know you can't focus on anything else. So very important, though. So hopefully you guys got the gist of what I was saying there, okay? So, Ernesto, the big change that is coming to the channel, it's actually not going to happen today. We had to postpone that change. So I'm going to lead you guys on and tell you that that big change is very most likely going to come next week. So yeah, we had some plans and the plans kind of fell through. So we'll see how that goes. So, okay. Brad Taylor, you said that you are unable to find the Rustbox app. Is that app for Android only? So Rustbox is actually not an app for your phone. Rustbox is a computer program. So Google search for your computer Rustbox. I personally do not know of a load calculation app for refrigeration for your phone at this time. Okay, but I'm not saying it won't come out soon. It's possible you could do the Rustbox app. Scott Savage, thank you very much. I'll address that right now. Okay. It's possible you could do the Rustbox app on your phone because it actually is just an Excel file. So it's possible that you can Google search Rustbox and just download Excel, and then you should be able to do it, okay? Hey, Gil, thank you very much, man. I really appreciate it, guys. Okay, so let's do the R22 versus 404. I know. Prime time. I see you're sick of the Headmaster talk. Okay. So R22 versus 404A. Well, it really depends on what you're working on. Okay. Each gas has its benefits and its downsides. All right. And actually, both of the refrigerants are being replaced very quickly. Okay. So, R22 is slowly being phased out. R22 had higher discharge temperatures. Okay. So your compressors tend to get a little bit hotter with R22. 404, but we had lower operating pressures with R22. 404A had lower discharge temperatures, but we had higher operating pressures. Okay. Obviously, R22 was not a blend, so sure, we're going to go with R22. It'd be the better gas of all of them. But when you get into all the environmentalist hippie people, they're going to tell you that the R22 is bad for the ozone, but also 404, I think, is arguably worse for the ozone. So, I mean, it's kind of a win between both. I mean, honestly, if I had to make a choice, I prefer R22, but obviously R22's prices are going up right now, okay? And as 404 is slowly being phased out, we've got new replacement refrigerants. R448A is the one that I've been using as my 404A replacement for medium temp and low temp. And it's a good gas. There's a little bit of a learning curve, okay, because it has a glide. 404A had a very, very minimal, not even almost really noticeable glide. So, you know, I mean, it really depends on what you're working on. R22 way back in the day was a great refrigerant in that when we were changing over from R12, we could still use the same compressors for the most part, and we could just change the metering device and then, you know, run with it. You know, you weren't supposed to, but a lot of people did. You know, I mean, it's just one of those things, you know, so it really just depends on what you're working on, you know, in your particular situation. So, all right, let's see what else. How do I feel about a tech moving into an office role? You know, it really depends on what your situation is. I really don't like being in an office. It drives me nuts. I can't handle it. So being in an office for me is, you know, my worst nightmare. I work in my office about once or twice a week usually, and I'm in there doing, you know, just normal remedial work, and I just feel like I don't accomplish anything. But you know, whatever floats your boat. If you're happy being in an office, then I say go for it, because it'll definitely, I mean, it'll work for you. You know what I'm saying? I don't see that there's anything wrong. Now, I also believe that every service manager should have been a service tech before he became a service manager. I do not believe that a service manager should have an office role and be commanding people and not know what they're actually doing out in the field. So some office work, I think you need to be a tech before you can work in the office. I think it's very important because your employees will respect you a lot more. Reefer Tech Mark, what would cause a transformer to trip without finding a rubbed out short? There's so many different things. There could have been a something on the circuit, the 24 volt or whatever the transformer is controlling. There could have been anything on there that has an overcurrent, that is shorted to ground. You could have all kinds of problems. So let's see. Sorry, I lost my train of thought there. So, yeah, I mean, it really could be anything, Mark. It just depends. You know, it could be a short, of course, that you can't see at the moment. It could be a component, a contactor that's getting stuck. It could be all kinds of different things. The sky is kind of the limit on that one, bud. You can feel free to send me an email and we can talk more. hvacrvideos@gmail.com. So let's see what else. Ice thickness probe was cut. Will splicing back together work right? Yeah, you should be fine. I mean, I prefer you to go ahead and change the ice thickness probe, but I mean, to get myself through a pinch, yeah, I would splice it back together. Permanently though, no, I would probably change it. But I mean, it depends on what type of ice machine. I'm assuming you're talking about like a Manitowoc ice machine. As long as it's not the microphone probe, then it should be fine. So that's what it was, Justin. I was like, why did Joe get muted? I was all confused for a minute, and I was like, wait, what happened? So that's all right. I kicked someone else out of the stream the other night on Zach's, and I didn't mean to. So, all right, let's see. Did you start? Did I start a Roth IRA and my employees? You have some R22 for sale. I see what you're saying. See, R22 isn't that very expensive here. I think it's only $450 a drum or something like that for a 30-pound drum. That's not that bad at all. So, all right, I'm going to go to my topics here real quick and cover a few things before I get to more of the chat. So if I haven't answered your question, feel free to post it again, okay? I already covered that. Okay, HVAC Apprentice asked me how to identify condensing units when you don't know which one's which. And he's referring to my video that I just posted where I had a walk-in cooler and a walk-in freezer, and I said I think this is the condensing unit, but they weren't labeled, okay? Now, experience is really going to help you to identify those properly, but we can even take that further. So let's talk about the different types of condensing units that we can have. We can also have multiplex systems. So that means that you have 4 evaporators in different regions downstairs in the restaurant, and you have 1 condensing unit on the roof. But let's say that you've got 5 condensing units that all do different evaporators. Okay, so let's get it even more confusing. How do we go about diagnosing or finding which condensing unit controls what? Okay, in a perfect world, you shut off the condensing unit for a day and you come back and see what's hot. Obviously, that's not going to work. Okay, so in that situation, on a multiplex system, what I would do is I would start turning off thermostats because it's a pump down system. I would start going downstairs and turning off thermostats, satisfying each evaporator coil and seeing which condensing unit turns off. Now, when I see a condensing unit turn off, I then don't just assume it's that one. Then I go back down and turn one of them back on to make sure that it turns back on, turn it off, make sure it turns back off, because you can be led in a direction that you don't want to go if you don't double check, okay? Now, in a walk-in freezer and a walk-in cooler, there's a couple different things. You can look at the refrigerant. In my situation, I had R22 and R404A. It's very, very rare that we use R22 for low temp gas, okay? It did happen, but it was very rare. So that's a pretty dead giveaway. You can also look at the size of the condensing unit. For the most part, low temp condensing units are usually going to be bigger than medium temps, but you also have to be careful because maybe you have a ginormous walk-in cooler and a very small walk-in freezer. So in that case, your low temp condensing unit may not be bigger, okay? You can also take the compressor data and look it up, but you have to be careful about that because nowadays we take compressors and we repurpose them all the time. We'll put a extended medium temp on a low temp, so you got to be careful about that. You can also go look at your metering device, or I'm sorry, no, that wouldn't work. But the other thing too is look at the defrost strategy. More than likely on a walk-in cooler is not going to have electric defrost for the most part. Okay, most of them won't unless it's a really rare case. So a walk-in cooler will probably have nothing hooked up to where you would have electric defrost. So if it's a standard 8145-20 defrost clock or a DTA V40 defrost clock, you would have nothing hooked up to the number 3 terminal, and you would have something hooked up to the number 4 terminal, okay? On the walk-in freezer time clock, typically you're going to have some sort of defrost termination, okay? So you'll usually have something hooked up to the X terminal. So there's a couple different methods to do it. What I suggest is once you figure out what is what, mark it with a paint marker, okay? Permanent markers are great. Sometimes I only have a permanent marker in my pocket, but permanent markers will fade in a couple weeks. A paint marker will usually last for years. And I usually mark it in a couple different spots so that way we can remember, okay? Hopefully that answers your question there. Let's go ahead and get to the chat. Okay, cool, guys. Ralph, on my last stream, I did some winners and we gave away, I think it was 6 prizes to 6 different people. And Ralph did get those shipped out. All but one. There was one person, and he'll get it shipped out tomorrow. So at least that was the last you told me, Ralph. Maybe he got them all shipped out today. But regardless, Ralph got those things shipped out, okay? And then also, I think I emailed everybody from the overtime show. I got your guys' stuff all shipped out too. So that should be popping out. All right, let's see what else we got in the chat going on here. Black Mist, thank you very much, man. Thank you guys for all the compliments. I really do appreciate the people that throw compliments in the videos and the chat and different things. I try to address them, but sometimes I miss them. So, okay, so Texas HVACR, what is the best procedure to bring oil back down from a reach-in evaporator? That could be very difficult when you have logged evaporators, okay? It's one of the most difficult things to get that oil out. And I'm going to be honest with you. Time, okay, is going to be one of the things. Oftentimes on reach-in coolers, they're not sized correctly for the proper refrigerant velocity to return oil. I have some really bad systems that have horrible oil return, and it's so bad that there's nothing you can do, okay? Obviously, putting proper P-traps in the right places, but in your situation, you're saying that the oil's stuck up high. Yeah, that's an interesting one. You may have to drain the oil out. It really depends. I mean, unless you can, increase refrigerant velocity, you're going to have a hard time getting that oil back. That's a very difficult thing. So sometimes, you know, depending on where the expansion valve's at, you can pull the expansion valve hat. In my situation, I work on a lot of Hvacr regions, the old multiplex systems, and they installed the expansion valves upside down, so the power heads are on the bottom. So in that situation, we just pull the power head off and let the oil drain out of the evaporator coil. Keep in mind, though, you got to get that oil back to the compressor. So if you drain it out of the system, you're going to need to make sure you add oil to the compressor. So unfortunately, I don't have a great answer for your question, Texas HVACR. It is a very difficult one. I'd appreciate some more context if you want to send me an email to hvacrvideos@gmail.com, and maybe we could talk a little bit more. So what happens when the evaporator turns to an ice block? John Curran. So when the evaporator turns into an ice block, the evaporator doesn't work anymore. Okay, so we're still feeding liquid refrigerant through the expansion valve. It's still coming out as a liquid vapor mixture into the evaporator coil. And then what happens is if the evaporator's frozen up, we no longer have heat transfer on the evaporator, or it's very little heat transfer, okay? And what happens is the refrigerant starts to collect, and it'll actually slug liquid, so we'll feed liquid back to the compressor, and it actually causes issues. So typically on a iced up evaporator, if it's running that way for a very long time, obviously your temperatures are going to go up, but you're also going to potentially damage your compressor. So you got to be very careful. When you see ice up situations, you definitely want to take care of them. Obviously, if you have an iced up evaporator, you've got more than likely some sort of a defrost issue, or a door being left open, or a thermostat being bad. There's all kinds of different situations that can cause an iced up evaporator, but you definitely want to take care of it as soon as possible. And you never want to try to adjust the refrigerant charge when you have an iced up evaporator also. So, all right, let's see what else we got. I ain't got no blood under my nose. It's just dirty. So it's just dirty. I'm trying to catch up to Bill. I'm gonna grow a beard like Bill. So, because I want to be like Bill. Yeah, definitely, Ernesto. I definitely was a little bit intoxicated on the overtime show. Just drinking sparkling water today. So got to keep my reputation on the up and up on the official videos channel. So, okay. Freddie, what happens if someone was to put the wrong cartridge inside the expansion valve? That's a really good question. It's either going to overfeed or it's going to underfeed, depending on the cartridge. So I'm assuming that you mean a build-a-valve, okay? Or a Sporlan Q valve or a BQ valve. In that situation, there's a cartridge mechanism that you put inside the expansion valve, and that's essentially what makes the tonnage. That's what lets the refrigerant, go through the expansion valve, or it creates the restriction inside of it. So yeah, it's either going to overfeed or underfeed depending on what you put in there. Now, you may be able to get away with it if it was a marginally sized valve as it is. You may be able to adjust the valve, but ideally you want to put the right cartridge back inside that valve for sure. So let me see what else we got going on. Let's see. Christian, you're asking if I can see your text. Yes, I can see your text. I didn't see your previous ones, though, so don't know what you had asked me before. But yes, I can see your text in the chat if that's what you're asking me. So what's the best way to verify correct airflow on a package unit, or how to determine RPM on a motor? Lorenzo. Okay. The best way to determine airflow on a package unit is to measure the airflow at the registers down inside the building with a flow hood. Okay, now that's not very practical because a lot of times it's very difficult to measure airflow, but a flow hood downstairs measuring the actual distributed air as it's passed already through the ductwork is going to tell you a lot, okay? The next thing, how do you test RPM on a motor? Well, to test RPM on a motor, what you're going to want to do is use a tachometer. There's a couple different styles of tachometers. There's the style that you actually have to press up against the pulley or the sheave while it's spinning. There's also the newer style that uses a piece of reflective tape, and what it does is it actually counts the revolutions per minute, or however you select it. You can do all kinds of different selections. So yeah, you can definitely do that with the RPM, or a tachometer, okay? So if you want to know the motor's RPMs, test it with the tachometer. Now, if you want to know the delivered RPMs, that's a little bit more difficult, but you can test that with a tachometer too, okay? I will say that the Measure Quick app does a really, really accurate estimation of airflow. So if you haven't tried it, I'd highly suggest it, okay? Measure Quick is the next best thing to physically getting down there and measuring the distributed airflow with a flow hood, okay? Flow hoods are very expensive. Most people don't have them. So I highly suggest you check that out. Measure Quick, it's free on all the app stores. The biggest thing about Measure Quick is you need to understand how to interpolate what it's telling you and how to properly measure things, okay? So for instance, on a package unit, it's very, very difficult to get readings without going down into the ductwork. Now, if you want to get the most accurate airflow estimation and the most accurate package unit performance measurements, okay, you want to measure the air temperature down, a ways away from the evaporator coil, okay, a ways away from the heat exchanger. Unfortunately, oftentimes the only place to measure air temperatures and different things like that on a package unit is right on the side of it, which is typically inches away from the heat exchanger and, probably about a foot away from the evaporator. So you're going to get some skewed numbers there, all right? So in a perfect world, you get down below the roof deck, you drill some holes, you measure in the plenum, okay, a ways away from the evaporator and heat exchanger, and then let Measure Quick do the math, and you can do some calculations. You can also traverse your duct, okay? Traversing your duct is going to be using an anemometer. I actually have an anemometer back here. Hold on. So this is a Fieldpiece STA2 anemometer, okay? It takes a measurement right here, and this can actually measure the airflow, the speed of the air, basically, and you can change the units. You traverse the duct, but the problem with an anemometer is you have to take estimated airflow or air measurement numbers, okay? So if you have a plenum, you're going to want to do many holes, all equally spaced out, and you're going to want to take equal measurements in whatever it is. So no matter how wide the plenum is, there's actual kind of numbers that you want to use. But an anemometer is another method of measuring airflow. Now with an anemometer, it's not necessarily going to tell you the CFM, even though this one will give you a CFM because you have to input the duct sizes. But that's what I'm trying to point out, is that you have to use some calculations based off of the duct sizes and the velocity of the air moving through that duct, and you're going to take an estimation. So you're not just going to take one reading, you're going to take multiple readings, and then you're going to find an average of those multiple readings. Because oftentimes, if you've ever used an anemometer, if you haven't, I implore you, try it out, because what you're going to actually see is it's going to kind of help you understand how crappy airflow is inside a ductwork. You'd imagine that a ductwork is square, or even a round duct, like the air is even all the way around, but it's not. Air is very turbulent. And so when you measure through with the anemometer, you're going to see all kinds of different air readings as you move the probe around. So it does help you to understand a little bit too. So an anemometer is another method of doing an airflow measurement, but that's going to be an estimation too, because you're going to take multiple readings. So hopefully I answered your question there for you, bud. Again, if I don't answer your guys' questions enough, give me more, send me an email, hvacrvideos@gmail.com. So let's see what we got going on here. Okay. Christian, you're saying that you have seen heat pump condenser for refrigeration walk-in with low pressure control and a receiver. Yeah, okay, so I've seen a lot of people do this. I actually used to do work for a golf course that all their equipment had condensers on the roof. Now, I don't know about heat pump condensers, but I guess it wouldn't hurt. That's kind of weird. Yeah, I guess you can use a heat pump. I don't know. Were they using hot gas defrost? Like, were they using the three-way valve, the reversing valve, as a hot gas defrost? I have seen people take residential condensers, especially in the past, because the capacities were close enough, and you could get your evaporator. There was enough room, basically, in the delivered capacity of the unit to run the equipment. So it is possible. It's kind of hacky if you think about it, but I mean, it's possible. Obviously, you'd have to add a receiver to it. And some solenoid valves and some safety controls, but it is, I mean, it's totally doable as long as the unit can deliver the right capacity. I mean, anything's possible. A compressor is a compressor, right? So it really just depends on the amount of delivered BTUs that you can put out with that condensing unit. But again, there's different ways you could do it. Let's talk about it. We'll talk about that later, Christian. So, All right, let's see what else we got going on here. I definitely missed a whole bunch of stuff in here, though. So let me see. Okay, so Ike, you said, why does the reversing valve switch back over after pressure equalizes and then kicks back over after start? The reverse valve never loses 24 volts. That's a really interesting question, Ike. There's obviously something going on in there. Excuse me. I don't know what's going on in your situation, Ike. So send me an email. We can talk about it a little bit more. Obviously, it sounds like you got a problem there with the valve or you know, something's going on inside that valve. All right, let's see what else we got going on here. Why do heat exchangers crack a lot? Really good question, John. Okay. So there's, let's just say there's two methods of a cracked heat exchanger, two reasons for a cracked heat exchanger. Okay, so I would say probably one of the number one reasons that heat exchangers crack is because of poor airflow. All right, so you got to remember that heat exchanger is going to deliver the same amount of heat no matter what the airflow is. If you have poor airflow through your ductwork, that heat exchanger is going to get hotter than it needs to. And it's going to stress the metals. Okay, the hotter and hotter it gets, the more the metals are going to get stressed and the more potential that you're going to have problems with it cracking later. All right, so I'd say probably the number one cause of bad heat exchangers, and it's just pure physics if you think about it, is poor airflow. Because if you don't have heat transfer across a heat exchanger, then it's going to get too hot. Now, it's always possible too that a heat exchanger doesn't get hot enough to trigger the limit switch and shut the system down, but it also runs hot all the time. I will say that there's probably 98%, let's just say 95% of our package units here in Southern California, whether they be, I mean, even residential, 95% of our air conditioning systems out here have poor, underperforming ductwork. Okay, we have leaking ducts, we have restricted ducts, we have all kinds of issues, all right? There's definitely a lack of information out there for people. I shouldn't say there's a lack of information, but there's a lack of knowledge for sure of the people doing the work are installing the equipment, okay? Oftentimes people take shortcuts and they just don't understand airflow and how to properly size ductwork. I'm not saying I'm an expert. I've just read a lot of books on it, but I certainly am not an expert on sizing ductwork. But I do know there's a whole science to it, and it's not just winging it. You don't size ductwork, you know, by rule of thumb. You don't say, if I have a 5,000 square foot house delivering 2,000 CF, or, you know, with a 5-ton delivering 2,000 CFMs of air, you know, what size should my ductwork be? Well, it really depends on what you need delivered to each room. Doing a proper load calculation, sizing your equipment, sizing the ductwork, you know, and figuring out your infiltration into the building and everything is really going to affect how the system operates. So poor ductwork, I would say, is the number one cause for bad heat exchangers, okay? A lot of people blame each individual manufacturer, and I don't really believe that. I mean, I'm sure there's faulty manufacturers in some cases, but I'd pretty be 100%, you know, I mean, it's pretty much all ductwork issues. Sorry, kind of tripping over my words there for a minute. All right, guys, let me get to one more thing on my list here, and then I'll get to some more of your guys' questions, okay? So when I was, my recent video, I had a walk-in cooler where we had an electrical short, okay? That was a situation, I just made the video. If you haven't watched it, check it out after the stream, okay? So I had an electrical short on a walk-in cooler, and I went through it thoroughly, and I found some issues, okay? The biggest thing was we had an electrical short because the wires were improperly run. And then I kind of stressed like how I like to run wires, you know, making sure that the unit is easily sorry, I am tripping over my words today. Easily serviceable, okay? So the way that I ran the wires, I can pull the fan motors and fan guards out. Now, I had a compressor contactor that was not, I could not take it apart, okay? It was a sealed contactor, and it showed me signs of wear. So I saw some white carbon-like substance on the contactor, and it kind of made me think that the inside of it was pitted out. Unfortunately, I couldn't take it apart. Normally, you can take the cover off, but I just couldn't do that. So I went ahead and decided to go ahead and replace the contactor, okay? Now, when I replaced the contactor, I miswired it. And I mentioned something as I was starting to replace the contactor. I did not know that this was going to happen. But I mentioned, you know, you need to pay attention to how these things are wired, number one. Okay, so yeah, sure, take a picture, take a video, whatever. but you also need to understand how the system works. In that situation, I miswired it. When I turned it on, nothing happened, okay? And I was able to stare at the contactor for a minute and just grab each wire and started looking. It didn't blow a breaker, so I knew it wasn't a short, so it had a direct short, so it had to be something that I just miswired. And then I started following the control voltage, understanding the logic of the unit, knowing what happened when the low pressure, when the high pressure, all those different things, and I was able to wire the contactor back up. And it was literally just a wire I misplaced and put it on the bottom, I think, number 2 terminal, and I should have put it on the top number 2 terminal. That was it. It's so important to pay attention and understand what we are working on. I think it's very scary right now because we have so many newer people coming into our trade and they don't necessarily understand what they're doing, okay? I understand I make videos on YouTube. I obviously leave a lot of stuff out of my videos because I don't want you guys to think that you can watch my video and just go fix something. You need to, to do a proper apprenticeship. You need to work underneath someone. My videos can help you, but you need to understand the sequence of operation of a system. You need to picture it in your head, okay? When you do that, it makes it easier to diagnose, and it also helps you to diagnose faster, all right? So I'm going to get back to the chat here and see what I missed. So let's see what else. What am I missing, guys? Make sure to throw the questions in caps lock if you can, okay? So what time am I going to be at the iHacky show? Great question, Oscar. So I plan on being at the iHacky trade show here in Southern California. It's going to be in Pasadena, California, actually. And it is going to be Wednesday. Let me look at my calendar right here. Wednesday, the 20th. Okay. So if any of you guys are in Southern California, I pretty much, hey, Zach, thank you very much, man. I really appreciate that, dude. I pretty much plan on being at the iHacky trade show all day long. So my plan, work permitting and everything, is that I'm going to get there first thing in the morning when they open, probably, 10 or 11 or whatever time they open, I'll get there. And I'm pretty much going to hang out. I don't know that I'll stay till the complete close, but I'll probably stay until 4 o'clock-ish, okay? Anybody that's interested in meeting up with me, hit me up on social media, whether it be Instagram or Facebook, and direct message me, whatever, and let me know when you're going to be there. And if I can, I'll wait up for you or try to figure it out, okay? So just message me. If you guys see me walking around, say hey to me, okay? Don't hesitate to stop me. If you see me talking to someone, that's cool. Just come up and say hey, shake my hand. I definitely want to meet everybody out there, okay? So if you guys see me, come say hi. What's my preferred? Storm Huffman asked me, what's my preferred method of defrosting evaporators? That's an easy one, man. Hot water. Disassemble the evaporators completely and use hot water. Personally, I know a lot of people say, hey, I use a torch, or hey, I use a pump sprayer. I like to use the hose when at all possible without making a huge mess. I always discuss with management or the kitchen staff and say, hey, I'm going to be in here and out of here a lot faster. If you let me get in here with the hose, it's going to make a little bit of a mess. I'll clean it up, or you guys can clean it up. Usually what I do is I approach management after I've defrosted a walk-in freezer. First off, always being careful too. Walk-in freezer, you never want to get water on the floor. It's either going to refreeze or it's going to damage something. But if I'm working on a reach-in cooler or something like that, I'll give them the option. Hey, I could do this real quick. It's going to make a mess. I'll definitely clean up the mess. But a lot of times I say, hey, do you want me to clean it up, or do you want one of your guys to clean it up? And a lot of times they end up cleaning it up themselves because they know that they're paying their guys a lot less than they're paying me an hour, basically, to do the, the cleanup and stuff. So, but yeah, hot water is my preferred method. I really don't care to use a torch or a heat gun or anything like that. Just hot water seems to be the most effective. Obviously, making sure that your drains are clear and everything's draining out. HVAC with Greg. Thank you very much for that super chat. And thank you, Zach and Adam. If I didn't say thank you to you guys already, I really, really appreciate it. So, Ike, I do see your email. I'll definitely address it when I get a chance. Okay. Favorite brand, condenser or furnace? I'm not a residential guy, so I'm not super comfortable with the residential equipment, but I would say if I had to make a guess, it would be some sort of ICP model. Carrier or something like that would probably be what I would put in my house. Actually, that's what's in my house right now, is like an Arco Air that I think we got from United Refrigeration or something like that. We didn't spend a bunch of money on it. Yeah, probably a Carrier product. But I mean, on the commercial side, commercial package units, a Lennox is my favorite package unit to work on, just because I'm super comfortable with their controls. It's not because I think Lennox is better than Trane or anything. It's because I'm comfortable with Lennox. Okay. So as far as favorite units, it's really all about what you're comfortable with. I'm not very comfortable, nor do I care for York equipment, But nothing against, some people love York equipment. They're just used to working on them. I'm just not that used to working on them. So every time I work on a York unit, I usually have to scratch my head. I do all right with Linux, and I do all right with Train. Some of the Train stuff can be a little confusing too when I'm talking about commercial. Again, I don't have a lot of experience with the residential stuff. So, all right. John Curran, should you call the health department if you see a ice machine that doesn't look clean? That's a really interesting question, John. I can't really advise you on that one because it would kind of be a conflict of interest for me. Okay. I would say that I'm not in the business to call the health department on my customers. I can say that one. Okay. But I can't really tell you what to do. But I mean, obviously the health department is there to protect you. Okay. To protect your health. So if you know of a situation where something's dirty, so be it. You got to do what you got to do. Now, I would be very careful. Jeff, thank you very much, man. I really appreciate that. I would be very careful. That was really cool, dude. I don't know if you're a technician or a consumer or what you are, but I mean, if you're a technician, it's probably not in your best interest to call the health department, because if someone caught wind of you calling the health department on them, they probably wouldn't call you ever again. Okay. And they'd probably tell your friends not to call you too. So I like to leave health department issues to consumers, and if they want to make phone calls about that, then so be it, All right. It was really cool, Jeff. Thank you for that super chat, dude. Really appreciate it. Wow, the chat is being really weird. It keeps disappearing on me. All right. Big picture diagnosis. That's right, Redo. Definitely big picture diagnosis. So, any advice on pursuing better pay and lower pay with family-friendly hours? Zach, very, very good question. All right. You need to balance the two. All right. What's better for you? For me personally, family is number one right now. Okay. I used to do the crazy, obviously I'm in a different position, but we used to work like crazy and go nuts over the summers and all that stuff and get crazy, stupid hours. And we came back from that because it was just too insane. So we like to keep it more of a family oriented. I want to be home for my kids and different things like that. Okay. Now, how to pursue better pay? Obviously, if you can, your best bet is to work with the company you're working with. Okay. However you can, talk to them, express your frustrations. But here's what I suggest. Don't just go to your boss and say, hey, man, I need a raise, okay? The best thing that I could suggest for someone to go ask for a raise is to go to their boss and politely say, hey, how else can I improve things at this company? What can I do to make things better? I want to take on more responsibilities. I want to become more of an asset to the company. What do I have to do? Because what you're doing is you're not just going to your boss asking for money. You're going to your boss and you're saying, hey, I would like to make more money. This is how I think I can do it. What else can I do? How can I help you? So that way the company can make more money and potentially I could make more money. Okay, obviously you want to try to work with the company you're working with before you jump ship and move on to someone else. If there's anything that I've learned in the position that I'm in is people will jump ship without communicating with you, and they won't even give you the opportunity. And it's like, and sure, there's lots of things that I have done wrong. Okay. So I'm not going to say I'm innocent in all the situations, but give me a shot. Give your employer a shot to make it right, to make it better. Be honest with them. I mean, you can have a candid conversation. It doesn't need to be an awkward, embarrassing thing. Don't let it get there. Just be honest. Like, hey, I want to be able to make more money. What do I have to do? Can I take on more responsibility? Can I move into a management position? All kinds of different things. So I don't know if I answered your question about that, Zach. Hopefully, if not, send me an email. I'll definitely talk about it some more. So let me see. Bill, thank you very much for that super chat, dude. I really appreciate it. It says, so your comment says, change the compressor on a -40 box recently. Appreciate all my help and insight, man. Oh, yeah. Right on, Bill. Thank you very much for watching, man. I really appreciate it. Okay. Acon 7XL, will I be at the AHR Expo in 2020? And the answer is yes. I can guarantee that you can catch me at the Sporlan booth at the AHR Expo. I will dedicate a couple hours a day of each day to, the first 2 days to the Sporlan booth. Okay, so I will be there. It'll be to be announced. I'm sure there's going to be meetups and different things with other YouTubers and stuff like that once we get closer to the AHR Expo. But yes, I already know I'm committed to hanging out at the Sporlan booth. It'll be publicized on all the social medias and everything. So if anybody does make it to the AHR show, I will be there too. Okay, I will also be giving a talk at the HVACR or HVAC school seminar 2 days or 3 days before the AHR show at Brian Orr's Kalos office, the business he works for. He's going to be doing a big giant training event, and I will be at that event too. So if any of you guys have tickets to that or considering it, definitely, because the speaker lineup for that event is awesome. Okay. I'm certainly looking at the speaker list wondering why I was invited to speak, because the people that are going to be there are awesome. One thing, I got a confirmation for sure today that Dick Wurz, the author of Commercial Refrigeration for Air Conditioning Technicians, he's going to be giving a talk before me. So I go after Dick Wurz. So Dick Wurz will be giving an educational talk on refrigeration. So that should be enough just to go to the event just for that alone. So, all right, let's see what else. Has big picture diagnosing ever backfired on me or gotten me way into the weeds? Storm. Well, sure. Yes, that is a good question. So yes, you can lose sight of what you're working on if you start looking at everything. It's very important, that you still keep sight of what you're there to do. But yes, when I say big picture diagnosis within that piece of equipment, obviously you know what the problem or the symptom is, right? Because you walk up and the compressor's bad. So we know we got to solve that. But it's the whole point of big picture diagnosis is once we change the compressor, if we can't find anything before we change it, we need to evaluate it after to figure out why it went bad. And of course, communicating with the customer is number one while all of that is going on. Okay. We don't just stand there for 2 days staring at it, fixing problem after problem to go to the customer with a $10,000 bill and say, I fixed it. No, we keep the customer with us the entire time, educating them like, here's what I'm finding. This is what the issues are. And that kind of stuff. Okay. So yes, it is possible to lose sight of where you're at, especially if there's a lot of complex problems. But that's what being a technician is. You got to be able to rein in on that, but it is definitely easy to get sidetracked and lost in what you're doing. So, all right. All kinds of stuff coming through here, guys. So if I'm missing your stuff, definitely throw it in again. Okay. When do I let a technician go? Well, that's a really hard subject, Jason. It really depends on a situation, okay? Obviously, if at all possible, you want to try to work with people. You want to try to communicate with people and, try to work with technicians. If you're doing everything correctly, a technician is going to know when it's time for them to get let go because you've been communicating with them the whole time, okay? In a perfect world, when you have issues with people, you're doing a write-up and, you communicate. A write-up doesn't mean the technician is fired, but you should bring the technician into the office. You should say, hey, we need to talk about this thing that happened. We're going to make an official write-up on here. We're just going to write down everything that happened. I need you to know this is a warning. You got to work on this, that kind of stuff. Okay. So if you do that enough, and I'm going to tell you right now, first off, we don't do that as a service company and we should. Okay. But when someone has a problem, because then that way there's no miscommunication, you let them know up front, hey, this is an issue that we had. We need to make sure it doesn't happen again. It's in writing. And then by the time it comes, technicians, honestly, they should know when it's time to fire them. I mean, sometimes, of course, you're going to have to let someone go, but you never want to, I never want to deal with that. It's so hard to let people go because for us, we're a small company. So people become family. You see these guys every day. So, hopefully you have mutual respect for each other and you can, communicate. And so that way you can just verbally tell each other like, hey, this is frustrating me. And then let them say it to you too. In my position, as an owner or manager, or whatever, if you're an owner or manager, you want to have good communication and you also want to be able to accept criticism. My guys can come up to me as long as they're respectful and tell me that they think I'm an asshole. I'm cool with that. Okay. They can tell me that and I'm not going to be a dick to them. I mean, it is what it is. If you have a problem with me, tell me. Okay. Hey, dude, you're being kind of hard on me. Okay. And I'll explain to them, you got to let me talk. Here's why I was being hard on you because this frustrated the heck out of me. Okay. But there's definitely certain areas that I can work in. So communication, number one. So I kind of went off on a tangent there. Let's see what I missed here. Favorite ice machine and why? Also, any future van tour, in-depth, or HVACR live videos soon? Yes and yes and yes. Favorite ice machine would be Hoshizaki's second favorite, Manitowoc ice machines, but Hoshizaki's number one. Standard traditional cubed Hoshizakis. Okay, Hoshizaki Flakers, my favorite flaker ice machine. If I'm dealing with nugget ice, it's a Fullet ice machine would be my favorite. Not a fan of Scotsman's, not a fan of Isomatic. Love me a Manitowoc CVD quiet cube machine. I work on those every single day. Again, just because I'm super comfortable with them. Nothing against the Isomatic. I just don't work on them very much. Okay. The old ones were pretty simple, but I just don't work on them that much. So van tour definitely coming up. I'll work on one of those. And HVACR Life. Yeah. I'm still talking to my wife about it, but yeah, we'll get back on those again. So can I get that refrigeration book autographed by Dick Wurs and do a giveaway? Huh, that's an interesting thought there, Familia. I don't know if you'd be up for autographing a book, but I'm sure we can figure something like that out. So, yeah, someone, don't let me forget that, Familia. Send me an email, hvacrvideos@gmail.com. So, Ernesto, I'm not leaving anybody, man. Ain't going nowhere. So, advice from new guys about graduating, about to graduate from school. Be humble. Keep your mouth shut. Listen to what people say when you go to your company. It's okay to express questions and concerns, but just be humble about it and don't be rude, okay? You need to just listen when you go to work for a service company. Remember that when you're going to a service company, don't be a dick about it, but you need to interview them just as much as they're interviewing you, okay? So what I mean by that is don't go to work for a service company and then realize 2 weeks later that it sucks and quit, okay? You should ask questions. You should figure out that you're going to like it or not. Now, I understand there's some things you can't figure out, but do your research. Talk to supply houses. Talk to other techs. You know, ask them to do ride-alongs before you commit to coming to work for them. Ride with them for 1 or 2 days. Ride with other service techs, different things like that, you know? So very important. Do I know what is the difference of cold and frozen, talking about science terms? What is the difference between cold and frozen? The lack of heat? I mean, that would be the difference between the two, right? One has less heat than the other. There really is no word, if you're talking scientific, cold. Cold doesn't exist, right? We just have the absence of heat, if you want to get all crazy and technical. You know, the absence of heat is cold, right? So definitely send me an email if you want to talk about that more. So let's see what else we got going on. Do I work on commercial kitchen gas and electric appliances? No, I do not. So it happened to me that I refused to work or repair on certain equipments, or I tried anyways. Yes, it has happened to me that I have. Yes, it has happened to me that I have refused to work on equipment. There are certain things that I just don't feel qualified to work on, so I will walk away. All right. I've had people call me for technical help when they're working on equipment that I have no business giving them technical help on, where I'm not too proud to say no. Okay. Because I know that I don't want to get myself into a situation where I break something or make it worse. So if I don't feel qualified, yes, I'm going to walk away from it. I'm going to tell the customer, hey, you know what? I'm not qualified to work on this. Here's some other suggestions of companies in my area that might be able to help you. So, Bill. You know what, Bill? We should watch Frozen together, dude. You see, Bill, I'm trying to become you, Bill. I got the beard going. So, you know, I think about a week or so, and I should have a beard just as big as you. So, all right. Did I go straight to school or get a job straight out? Have I always done commercial? HVAC with Greg. So, Greg, my story is that I grew up working for my father. My father started the business that I work for now. Now we run it together, okay? I learned from a very young age, elementary school, junior high school, working summers, days off, school days off, and different things like that, helping my dad out. I went into high school, and junior high, decided I didn't want to do this anymore. This just wasn't, it was just too hot. I didn't like being on the roof, okay? Because all I was doing was helping, changing swamp cooler pads, filters, different things like that. So when I graduated high school, I decided, I graduated high school, I was working at a body shop, working on cars, an auto body shop. And I did that for about a year. And I just decided this isn't what I wanted to do anymore. I really didn't have any ambitions to do anything else, and I think out of just pure like, hey, I got nothing else to do. Hey, Dad, can I come work for you? And he said, yeah. I can remember the conversation. I can remember asking him. He just said, yeah, you can come work for me. You know, how about we start in 2 months or something like that? Because he had to get some things in line and get some maintenance contracts set up. So I went to work for my dad in 2002, April of 2002. And I kind of already had a little bit of experience, but my dad said right then and there, he goes, you have to go to school. So I went to night school at my local community college, started taking night classes semester after semester, getting all my stuff done. And in all actuality, I never even finished the program. I think I'm like 2 classes shy. I think I need to take like a technical math class, if I remember right, and a welding class. and I think codes and standards at the time was, so I 3 classes shy of getting a certificate. But I got what I needed. And then but that didn't just prepare me for everything. Then I started working. I was an apprentice. I was working my way up. I worked with my cousin that used to work for me or work with us. I learned from my dad, and I just worked my way up. Out of pure curiosity, I started to ask questions, not in the rude way. And I started to realize that some of the things I was taught was not correct. I was taught a lot of old school methods, beer can cold, different things like that. And, you know, I had a nagging feeling inside of me telling me that this wasn't right. So I started to read. And that's where I kind of got to the point that I'm at now. You know, it's just by reading and being curious and researching. And, you know, just, again, I don't know everything. I'll never know everything. And I don't ever say that I know everything. I'm still learning every single day. And the whole point of these videos and these streams is just to share the little bit of knowledge that I have with you guys. So, all right. Let's see. Is it possible to do a temporary fix to a heat exchanger in an emergency? No, HVAC rookie. Absolutely no. That is a massive, massive liability. So you do that, you set yourself up for the biggest lawsuit everywhere. Because if you think about it, a heat exchanger fails in the perfect situation. It's very rare that this actually happens, but in the perfect situation, it fills a home with carbon monoxide. Again, it's probably like, you know, 99.9% chance that it's not going to happen, but it fills a home with carbon monoxide, that 0.10 whatever chance, and you kill everybody in the house. First off, you will never be able to live with yourself, but second, you're done. So no, never repair a heat exchanger. Don't care what you see people putting sleeves on them. Don't do it. Just walk away. So, all right, I'm going to scroll down. If I missed anything, repost it again, guys. I know there's a lot of stuff going on in here. All right. Oh, that's funny. All right. Okay, so I want to discuss being practical. All right, being practical. Understand something. I am not perfect, and I've been trying to show that a little bit more lately in my videos. Is show my mistakes and show and point out the imperfections of my work, guys. I got a comment last week saying, "Oh my gosh, you're the first video on YouTube I've seen someone using nitrogen. I'm so glad." And it was a really nice comment. And I addressed it with the guy right away. And I just, look, I don't always braze with nitrogen, guys. Okay, there's times that you can't. You have to be realistic and understand. There's certain times that you can follow best practices. There's certain times you can't, okay? Obviously, you want to follow certain best practices like pulling a vacuum on a system. That's a no-brainer, okay? You got to pull a vacuum. But I mean, am I always correct? You know, no. Do I do stupid things? Yes. Do I accidentally turn something off and not check voltage before I stick my hands in there? Yes, I've done it. Is it stupid? Yes. You know, I mean, I'm not perfect, okay? I do not always braze with nitrogen. I do not pull a perfect vacuum every single time because sometimes you can't pull a perfect vacuum. I've actually even argued to say majority of the time you can't pull a perfect vacuum, especially on older equipment. It just has leaks, and that's just what you got to deal with, okay? So I don't want to fool you guys and make you think I'm some saint. I am not. I am just a normal person just like you guys, okay? There's nothing special about me other than I have a little bit of knowledge. That's it, okay? And I just ask questions. So let's see what else we got in the chat here. All right. Not seeing anything there. Okay, any more questions? Definitely, guys, throw them in caps lock because I see so much scrolling by, I don't even know what to look for. So let's see. All right, in my video that I released last week, we worked on a walk-in cooler, and there was a little test, and I had like 2 questions asking me why I did this, so I just kind of wanted to point it out. It was a really simple test, okay? And that was when I tested the thermostat. When I tested the thermostat inside the video, after the unit was running, I went inside the box and I took note of what the box temperature was, okay? Because I had my smart probe in there, my JobLink probe. So I knew what the box temperature was. And then I went to the thermostat and I turned it off and I turned it on. And what I listened for was the click of the solenoid valve. I listened to see what the temperature of the thermostat, the setting on the dial was when it clicked, okay? That told me that the thermostat was likely working, and that also told me that I wired it correctly, which was another test to make sure that nothing blew up in my face. But I will do that occasionally, just go turn the thermostat just to see how accurate it is. It is very, very common for a mechanical thermostat to read off. So to click, let's just say it's 40 degrees in the box, and it clicks at like 32. That's very common on a mechanical stat. As long as it's not really old, sometimes you just have to adjust them accordingly, okay? Another thing that someone had asked me about was pump down systems. And I kind of mentioned that I would kind of discuss a pump down system really quick. Okay. So we've talked about this before. A pump down system. Okay, first off, pumping down a system. Pumping down a system is stopping the refrigerant flow while the compressor is still flowing until it gets to a certain pressure and then the system shuts off. Okay, the reason why we do pump downs for the most part is to keep refrigerant from migrating, liquid refrigerant from migrating into the shell of the compressor and then causing a problem on startup. Okay, so on most systems, what we will do is we will have a pump down. So when it satisfies, okay, there's another reason for a pump down too. I should cover that. If you have a multiplex system, so if you have multiple evaporators controlling different equipment, you obviously have to have a way to shut off evaporators individually. Okay, so if we have multiple evaporators, we're going to have a pump down circuit on every single evaporator. They're each going to have a liquid line solenoid valve. If we didn't, then each evaporator could potentially get too cold and freeze the product and ruin product. Okay, so if we have 10 evaporators in 10 different boxes, each one's going to have its own thermostat and solenoid valve. So that way the system, more than likely, okay, there's some situations where you won't, but for the most part, they're all going to have their own individual thermostats and solenoids. Okay, so the thermostat is basically just going to break one leg of power going to the solenoid valve. So you're going to have 2 legs of power going to the solenoid valve, okay? And JJ, thank you very much, JJ Services. I really appreciate that super chat. That was really cool. So you're going to have 2 lines of power going to that solenoid valve. And if I had a schematic, I'd draw it out for you guys, okay? If I take a thermostat, think of a thermostat as a light switch for your house. A light switch just interrupts power to something, right? So if you have a thermostat and it just interrupts power to that, then that solenoid coil is no longer going to get energized, okay? So, and I'm flashing gang signs right now, guys. So if you want to know what that is, if you guys have seen any of those, my daughter and I joke. There's like a meme going around Facebook where it's a sign and it shows you what the different gang signs mean, and it's all jokes, and it's the funniest thing. Like there's one like this, and it's like, "Hey, bro, I got to poop." That's what it means. So anyway, sorry, went off on a tangent there. But yeah, so a pump down system. The thermostat is going to interrupt power to the solenoid valve, and the solenoid valve is going to stop the flow of refrigerant at that point, okay? So then the rest of the system's still going to get liquid refrigerant going to the expansion valve, but that one particular circuit that is satisfied won't get liquid refrigerant going to the expansion valve. So typically, not always, but typically, you're only going to interrupt the liquid line with a solenoid valve. Now, on some systems, they might use a suction stop solenoid valve too. Okay, that's a whole nother situation. You'll see that in like gravity cases and different things like that. But for the most part, you're only going to see one solenoid valve on the liquid line, and the suction is still going to be common amongst everything. So the suction will still be connected. You'll still have suction pressure, but the refrigerant just won't flow through from one side to the other. Okay, so hopefully I kind of explained the pump down systems a little bit. If I didn't, send me an email to hvacrvideos@gmail.com. Okay, let's see what else. Did anybody get the movie quote? Yeah, I always go off on tangents, fluffy anus. I'm curious if anybody got the movie quote. I know this is a really, really hard movie quote, so tell me if anybody got it. I'm curious. So I wonder if there's a way I can, if someone types in the name of the movie, like Nightbot Tells Me or something like that. That'd be kind of cool. Fluffy Anus, you want to be a guest on? Yeah, I'd really be curious to know who you are, Fluffy Anus. So yeah, you should be a guest on Overtime. All right. Have I tried the solder weld kit? Yes, Ernesto, I have tried the solder weld kit. I have it, but the only thing I've really used out of it is the 15% Silphos brazing rods, the round ones. I haven't had an opportunity to use any of the aluminum brazing stuff, but I have the whole kit. So yeah, you are HVAC apprentice. It is heavy metal. That's right. Right on, dude. I was curious if anybody would get that. So, all right. Let's see. You do a lot of air conditioning work, Sagittarius 88. In the automotive field, the term superheat is not something that you're familiar with. Brief explanation. Brief explanation without getting all crazy technical. Superheat is going to be a measurement of the performance of the evaporator. Okay, I know that's not 100% correct, but essentially, if I say this correctly, it's the amount of heat that the system absorbs after the refrigerant is completely saturated. See, this is why I have to second guess myself when I talk about superheat. Now, let me tell you that superheat does still happen in the automotive field, okay? All the same refrigeration practices apply to the automotive field. So your condenser rejects heat, your evaporator absorbs heat, okay? Your compressor is a compression device, and it's pumping the refrigerant through. So the refrigerant system is the same. It's just you have different components. Your compressor might be ran off of belt driven, or it might be 12 volts. Who knows? Okay. But you still have the same concepts. Okay. The evaporator absorbs. You have a metering device, whether it be a fixed restrictor or an expansion valve, you're still going to have them. Your system still has superheat. Your system still has subcooling. It just isn't really something that they measure on the automotive side. Okay. Typically, you're just going to go off of pressures and then performance, temperatures, and different things like that. But it does still exist. It's definitely a hard metric to get on the automotive side. Typically on the automotive side, my understanding is you guys have extremely oversized evaporator coils. You run extremely low temps. If you guys have ever stuck in your thermometer into an automotive air conditioner vent, you can see temperatures in the 40s. Sometimes you'll see your breath. You'll see it in the high 30s. I mean, so it's a very, very, it's just a standard refrigeration system. So, all right, let's see what else. I probably butchered that superheat thing right there. So, let me see. Let me see what else we got. Hey, Justin, I see you're in there right now. All right. Let me see. Did you change your name, Justin? I just noticed that right now. It says Beaver HVAC now. All right, guys, let's throw some more questions in here. I'll definitely see what I can do. What do you use to braze aluminum to copper? So Nathan Peterson, Solder Weld has some great products for aluminum to copper. I think it's called their Alcop filler rods, and you can use that to braze aluminum to copper. I've never done it. I've just read and saw all kinds of videos. So just Google search Solder Weld aluminum or Alcop, and I believe it'll tell you all about it. So when do I condemn a control board to be bad? Oscar Palma, I will say right now on the commercial side, it's majority of the times it's not the control board that's failed. Or if it is the control board, something made it fail. But I mean, it's just basically following your sequence of operation. If the system's working right and you've tested everything and the only thing that's wrong is the logic in the control board, then you're going to go down that path. But I'm going to exhaust all my resources to evaluate everything else in the system before I diagnose a control board. So, all right. So let's see. Rock Houndin Reefer. How's the new ULN laws and the AQMD treating me? You seem mostly commercial as well. Yeah, I am mostly commercial, and we definitely do have some new AQMD laws here in Southern California. We have all kinds of different rules. It's a ever-changing game. Every single day, something new, it seems like, is coming out. Okay, all kinds of different restrictions. I'd like to be able to answer your question a little bit more. If you want to send me an email to hvacrvideos@gmail.com, and I can get some more context there. So, hey Susie, how you doing tonight? All right, have I worked on a Polaris underbench 3-door freezer, and have I had any videos? No, Brett from Brazing. I have not worked on a Polaris underbench freezer before. Don't even know that I even knew Polaris as a refrigerator manufacturer's name. The only Polaris I know in the United States here would be the motorcycle manufacturer. So I didn't know that there's a brand of refrigerator named Polaris. Thoughts on Stay Bright 8? I got nothing bad to say about it. I don't use Stay Bright 8. I'm 15% Silphos or 56% silver, period. That's all that I use for brazing rods. I'm not a Stay Bright 8 fan. I've read the science behind it. I've read all the stuff, all that good stuff, but it's just not my cup of tea. I've fixed lots of leaks on Stay Bright 8 or soft solder types. And what it is Stay Bright 8. I've fixed lots of leaks on it. Just not a fan myself. So I'm a 15% Silphos or 56% silver is what I use. So, all right. Oh, right on, Big Joe. Appreciate you coming in, man. So let's see. Is it possible to swap a VFD in place of a ECM without issues? HVAC rookie. I mean, anything's possible. You'd have to have a VFD and you'd have to have an inverter duty motor. But, you're not going to be able to just use the same motor. No. But, I mean, I guess it's possible. I mean, if you can get it to fit and everything to work properly. A VFD is compatible with almost anything. I mean, as long as you can wire it correctly and have the right motor for it to control. So just got to have the right kind of motor. That's all. So let me see. Does it make sense changing out bad components on a control board or buying a new board? That's a really good question, Redo. Personally, as a contractor, the liability is too high for me to try to change components on a control board. So I won't. Okay. Yes, you can probably order a new capacitor or different things, but it's not something that I will do. We just change the board if that's the case. So, Have I ever worked on a ammonia equipment, or do I recommend learning it? Ammonia is the heavy industrial stuff. I know there's lots of good money to be made in ammonia. So if that's something you're interested in, there's lots of people doing it. And it's definitely something you should learn. RETA, I believe, is the trade organization of people that work on ammonia stuff. You should definitely check them out. It's RETA, I believe, and I don't know what that stands for. But I'm part of a trade organization called RSES, and that's Refrigeration Service Engineers Society. And they're kind of our sister organization, but they deal with ammonia industrial stuff. So check them out. Andrew, dude, thank you very much, man. All right, I really appreciate that super chat, bud. All right, let's see what else we got going on. Is this going to be posted late? Yes, Ray. This will come up on my channel later, so feel free to check it out. So, let's see what else. Does it? Okay, so I answered that question. All right, yeah, I really appreciate hitting the thumbs up, like Rookie said there, because it definitely helps me out. So, will a water regulating capillary nut have a Schrader depressor? You're thinking probably not. Probably need to recover the whole charge. Can't remember. That's a really good question, Happy Guy. I really don't know, man. It depends on each individual manufacturer. Sometimes they put them there, sometimes they don't. So, Fluke196, thank you very much. You guys with the super chats, these are awesome. I really, really appreciate them, guys. So thank you so very much for those. All right, let's see. Let's see what I got else in here. I think I covered that. I covered that. All right, gentlemen. Am I going to be at the iHacky on Wednesday? Brian Gonzalez. Yes, I am, Brian. I plan on being there probably first thing when they open and staying until about probably 4 o'clock in the afternoon. So feel free to hit me up on social media, whether it be an Instagram DM or Facebook Messenger, whatever. Send me a message. Let me know if you're going to be there and what time you're going to be there. And that way we can say, hey, if anybody in here is coming in right now, feel free to message me or whatever on any of the social medias. And then also, don't hesitate to stop me if you guys see me there. Say what's up. Don't just let me walk by, okay? Let's see what else. Cocaine is bad. Yes, Adam, cocaine is bad, for sure. Sorry. All right. Yeah, I covered that one. All right. Makes you figure out calls a lot faster, Fluffy Anus. Yeah, I'm sure it does there. Is it possible to use a universal compressor when you can't find the OEM part? Jesse Torres, it is completely possible to use a universal compressor. I wouldn't say universal, though, because each compressor has its own specific use, okay? So you're going to have the BTU output. You're going to have the temperature at which the compressor was designed to have suction gas coming back to it, okay? But yes, you can use an aftermarket compressor. The Copeland mobile app, okay, is a very good app if you don't have it, and it definitely helps you. Copeland also has some cross-referencing for different compressors, so you can take other manufacturers and cross-reference to a Copeland compressor. I believe Danfoss probably has some stuff out there too, so it is definitely possible to use an aftermarket compressor. I highly suggest using OEM whenever possible, but sometimes you can't. So yeah, there's nothing wrong with it. It's just got to be sized correctly. A touch of ADD. I've got a lot of ADD. So thank you very much for that super chat, man. I really appreciate it. Really, really appreciate it. And Rookie, thank you very much, man, for that super chat too. Sometimes I forget to acknowledge you guys, but you guys are awesome. Rito Felix, am I a fan of hydrocarbon equipment? I mean, I work on a lot of hydrocarbon refrigerant. I have a lot of R290 systems out there. Most every restaurant, anything they order new from this point forward is going to be R290. It's just some more precautions to work on. I've got some videos on it. So if you just go into my channel and search R290, I think there's like maybe three videos working on R290 equipment. Nothing too crazy, just some new safety stuff you got to follow. Still a refrigeration system. So let's see. Yamo says Mota is bad. Yeah, it is bad for sure. So, all right, let me see what else we got going on here. Who don't I like? I'm not ignoring you, Rookie. What kind of question you asking that I'm missing? You just got to keep posting your questions if I miss them. Can you have a blue car on the shelf? Oh, you want my blue car? Which blue car? Because there's a VW Bug, and then there's a 68 Mustang. So you got to tell me which one you want, Rookie. So the 68 Mustang is actually really cool. Hold on. It's actually a Lego, dude. My daughter and I built it. Yeah. My daughter loves building Legos, so we built this together. I shouldn't say together. She built it. I just helped her with a few things. All right. Joe, thank you very much, man. Really appreciate the super chat. Fluke196. Yeah, must check nose for R290 for sure. Yeah, you could smell it for sure. So what age do I plan to retire at? If I could retire today, I would, but I can't. So financially, I could probably retire when I'm 90 because I live in California. So I could probably afford to retire when I'm 90. All right. Any of them? Yeah, Ruben. You know, surprisingly, again, thank you so much for these super chats, guys. You guys are awesome. Thank you very much. Bthome957. That's awesome, dude. No, I don't work on larger chillers, but there's plenty of guys in here that work on larger chillers for sure. Actually, Ulysses is in here too. Ulysses works on ammonia. Someone was asking questions about ammonia earlier. I have no business even talking about it. So, do I ever see any of the old belt drive refrigeration compressors still in use? There are still belt drive compressors in use. I do not come across them, no. I've only seen one belt drive compressor in my life. So, no. I've never even worked on it. I just got to see it. So, let me see what I'm missing here. All right. All right. Is it okay to overamp an exhaust fan? And what should the static pressure be in an exhaust fan? Also, how do you increase the positive pressure instead of negative pressure back into the building? Thanks. Fluke196. Dude, that isn't... Thank you very much for that super chat. Really awesome, man. You are the man. Thank you very much. Molly, first off, you got a pretty loaded question there. Is it okay to overamp an exhaust fan? No. Okay. Overamp of an exhaust fan, that would be the motor. The motor is working too hard, okay? Something is wrong if the motor is working too hard, okay? The next part of your question, what should the static pressure be in an exhaust fan? It really depends on what the manufacturer spec'd it to be, okay? So I've seen exhaust fans that have static pressure recommendations of up to 2 inches. I've seen exhaust fans that have static pressure recommendations below 1/2 inch. It depends, okay? Depends on what the manufacturer set it up to be. You would have to lean on each individual manufacturer to figure out what they recommend the static pressure should be. I will say that static pressure typically isn't a measurement that we use a lot on exhaust fans, simply because you'd have to drill holes into the plenum of the exhaust fan or the grease duct. And for the most part, you're not supposed to drill holes in those. I've done it in severe instances where I needed to verify some airflow issues, and I've done it, but you're not supposed to typically drill holes into exhaust fans, okay? Next part of your question, how do you increase positive pressure instead of negative pressure? Let's go over this real quick. Hey, Joe, dude, you guys are awesome with these super chats, man. Thank you guys very much. So let's talk about building balance really quick, Molly. I'm going to go through this. I'm not going to spend hours on it, but I've said this many times before. I'll say it again. The easiest way to understand building balance is if you can picture someone putting a paper bag over their mouth, not over their head, putting a paper bag over their mouth and hyperventilating. Okay? Breathing with the bag pressed up against their mouth. When you suck the air in, the bag is going to collapse. Okay? When you blow air out, the bag is going to pressurize. Okay, now, if you do that same test, but you cut a hole in the bottom of the bag, if you cut that hole to the right size, when you suck on the bag, nothing's going to happen. The air is going to pass through the bag. Okay? That's the easiest way I could describe a building balance. So, with that being said, the building is the bag. The exhaust fan is your mouth pulling the air out of the bag, and the hole in the bottom is the makeup air. If you pull air out of a building, you have to put air back in. Andrew, dude, thank you for that super chat, man. I really appreciate it, and I like the choo-choos. If you pull air out of a building, you have to put air back into the building, okay? If you pull too much air and there's not enough air coming back into the building, that is what we call a negative air balance. Negative air balance is when you have too much exhaust air, so the building goes into a negative air pressure. Oftentimes, the sign of negative air pressures, if you guys have ever gone to a restaurant or a building, you go to open the doors and the doors are really hard to open. And then when you get them open, and that's assuming they're not locked because you're an idiot, when you get the doors open, okay, when they're not locked, and then all of a sudden there's a rush of air that goes right by you. That's because that building is operating in a negative air pressure. So when you open the door, you relieved the negative air pressure and all the positive air from outside came into the building. So how do we make a building not negative and make it go into the positive? We add air into the building, okay? Makeup air. We call that makeup air. Makeup air is added to the building in different methods to alleviate the negative air pressure, okay? So typically here in Southern California, We want to have a building that is ever so slightly positive. I am not a certified air balance person. I know just enough to get me in trouble, but I know that our buildings, we want them to be slightly positive. We don't want them to be so positive that it blows the doors open. That is possible too. We don't want that, but we don't want to be bringing outside air into the building. I'd rather push a little bit of conditioned air outside of the building than bring in unconditioned air from the outside into the building, okay? Conditioned air is filtered, right? It's running through filters, so it's theoretically somewhat cleaner than the outside air. That's a, arguable question or arguable point there because, whatever. But that's the basic air balance description, so hopefully that helped you, Molly. So if you have a negative air, you need to add positive pressure into that building and or reduce the negative air by slowing down the exhaust fan. So hopefully I answered your question. And again, guys, these super chats are freaking awesome, dude. Thank you very much. All right, let's see. Does anyone know where Ted has been? No, I don't know where Ted has been. I'll have to send Ted an email. So, all right, let me see what else. You need more makeup air videos. I'll see what I can do. I don't really have much makeup air stuff to do right now, but I'm sure something will come up. So, yeah, exactly. Black Mist. You like my quotes there, huh? All right. Hey, Ruben, thank you very much, man. The door is locked, you idiot. Thanks, bud. I really appreciate that, man. That's awesome, dude. All right. 6 air changes an hour. That's a whole nother thing. Okay, you got it. John has a great point. You have to add in, we have something we call sick building syndrome. Okay. So if we have a building and we're not bringing fresh air into the building, okay, we can start to create what we call sick building syndrome. This will typically happen in office buildings, okay? So that, again, I'm kind of going off on a whole thing, but John, you said air exchanges, and that's immediately what I thought of with air exchanges, okay? So a negative air pressure problem is not just associated with a restaurant, okay? You can have negative air pressure problems at your house. So let me ask you this. If you, like my house right now, my house runs negative, okay? So what does that mean? What that means is that I'm creating a negative air pressure in my house somehow. So and think about that. I have no outside air, I have no outside air dampers or anything like that on my air conditioner at my house. Okay. So my house has a 4-ton split system and I'm running a negative air pressure. So what that means is that I have duct leaks more than likely on my supply air side because my return air is pulling the air from my house and it's blowing it, but it's not all making it back into my house. Some of it's getting into my attic. And so what that means is my return air is still pulling, but keeps pushing some of the air into my attic. So that's creating a negative air pressure. It also doesn't help that I have a fireplace, but I keep the damper closed on it. But I have a negative air pressure problem. It's one of those things where I just don't address it, But so it's possible to have negative air pressure in your homes. Okay, that can create issues too. You can have them in buildings. So in a building, we have to do air exchanges. So there's a whole nother code that says you have to bring so much fresh air per person in the building because we don't want people's CO2 that you're breathing out basically making the other people in the building sick or sleepy. Okay. So we have to do air exchanges too. When you get into air balance, it gets like super technical and super weird. And there's all kinds of crazy requirements and codes you have to follow. So air balance is a whole nother side of this industry. Typically, certified air balance people are not air conditioning technicians because it's a whole nother science. It's definitely all connected and related, but for the most part, you don't see a lot of air conditioning technicians that are air balance technicians also. But they do exist, but it's just not very common. So air balance is always something that I've wanted to learn. I've always wanted to get certified in air balance. One of these days I'll do it. So how do I go about sizing a unit for a walk-in freezer? Well, it's pretty simple, okay? You have to know the infiltrating load, okay? The heat load coming into the building. Hey, Bill, thank you. Hey, Frozen 2 tickets. Let's do it, bud. Thanks, man. Maybe we can watch it together, Bill. We can do like a Frozen real beard on you and like kind of half fake beard on me, and maybe we can watch together. We can like pretend we're in the same room. Am I getting a little too like creepy there? Appreciate that, dude. All right, so let me see. How do you go about sizing a walk-in freezer? So basically, you need to figure out the heat load required to cool that walk-in freezer. You got to take into account the infiltrating air into the box. I'll usually use a load calculation software. The one that I use most commonly is called Rustbox. It's made by Russell Refrigeration. If you just Google search Russell Refrigeration, they're owned by Carrier now or someone. HTPG. Yeah, Heat Transfer Products Group. But they have a load calculation software. You can use it for any equipment. It's just going to give you a basic load calculation. You input the city and state you live in, your nearest. The best bet is to find your nearest Air Force base, find your, if it's close enough to you, to find your actual conditions where you live, the ambient air temps and different things like that. You're going to do a calculation to find out how many BTUs you need. You also need to know how many people are in the box on a regular basis. Is it big enough to drive cars in? Is it small enough to only have one door? All that stuff. You just basically have to figure out the infiltrating heat load and the heat load operating within the box. And then you're going to be able to calculate how big your equipment needs to be or how small it needs to be. Okay, so use one of those load calculation software. Trenton has one and Russell has one. And I believe Keep Right might have one too. So you can look that up. Let's see what I missed here. VFD versus ECM versus AC versus DC motors. Which one is good for an exhaust fan? What exhaust fans are good for energy efficiency? Well, Molly, let's get really confusing here, but an ECM motor is a DC motor and a VFD motor is an AC motor, if that's what you're asking. So it really depends on your situation. I mean, a VFD motor is, if a VFD driven motor is more capable of slowing down and speeding up on the fly. ECM motors are typically programmed, and usually you can't adjust on the fly for the most part, but it is possible. That's kind of a loaded question. Which one's better for energy efficiency? That's beyond my pay grade. I'm not that smart. I just know how to say they're bad and put new ones in. So, all right, let's see what else. What is the biggest near miss I've ever had? Biggest near miss. I fell off a ladder. That's the biggest one. I was climbing up a ladder. I had my Vito Tech Pack backpack on my back, and I had my my torch caddy carrying my oxygen and acetylene torch bottles inside on my left hand, and I was climbing up the ladder with one hand. Major OSHA violation, right? I missed the top rung, and I fell off the ladder. It was literally like a second, right, of me falling, and I remember I thought of so many things while I was falling. It's funny, you have that near-death experience, right? I wasn't going to die, but I mean, I was, you have that flash between your eyes. And I remember thinking, oh crap, I don't have enough money saved up to be in the hospital. What am I going to do? And then next thing you know, I hit. And what I hit was I lucked out. As I was climbing up the ladder, I climbed through a cage. They had their back dock caged off, and I landed on a chain link fence that was laying across the back dock area so that people couldn't break into the back dock. I landed on the chain link fence. My Vito Tech Pack broke my fall, and I landed on the chain link like it was a hammock. Boom. That was my biggest near miss. Almost got hurt. Who knows what could have happened. Wearing the Vito backpack, if I'd fallen on the ground and bent over that could have broke my back, all kinds of things. So I'd say that was probably my biggest near miss, was falling off and landing on that fence. All right, let's see what else we got going on. Who got timed out? All right, let's see what else. All right, guys. Let me see. Need a rope. Yeah, that was the moment. I was trying to be Superman. I rope everything now. So definitely. Most important memories flash before your eyes. Kids being born, marriages, etc. No, money flashed before my eyes. HVAC with Greg. I was just thinking, I can't afford this. I knew I wasn't going to die, but I just remember thinking, I can't afford this. This is going to suck. So one time I had my arm through a sheave on a 15-ton RTU, looked over, and the disconnect was on. Oh, yeah, that's a scary thing too there, John McMaster. So, yeah, glad I got lucky. Thank you very much, Fluke. That was definitely scary. So, all right, let's see. 120 or 240 for exhaust fans. Molly, 240 is more efficient. 120 less efficient, higher amp draws, more expensive, bigger wire size. 240 stuff is typically a little bit cheaper. 243 phase is better. 483 phase is better. It's funny because once you hit that 243 phase mark, the equipment is relatively cheap and the electricity is relatively cheap. Once you hit the 480, the components can be a lot smaller. The wiring size can be a lot smaller. The parts typically cost more. The energy efficiency, I think, still exists there. There's a whole ball game. Again, you're getting super like engineering questions where my brain really isn't that smart to be able to answer those. So, does Testo Smart Probes tell you major faulty log as field piece probe does. Nahom. Okay, so Nahom, I believe I understand your question. I think that's how you say your name. And yeah, the Testo Smart Probes do have an app that will help you to evaluate systems. The Testo Smart Probes will also work with an app called Measure Quick. I highly suggest you look into downloading the app Measure Quick. It will work with the Testo or the field piece ones. It is a great app, and it really helps you to diagnose equipment. So hopefully that answers your question for you, bud. Should you see bubbles in your sight glass when your headmaster is bypassing? No, but when a headmaster first bypasses, again, you need to let a system stabilize no matter what's happening with the system before you make sure or you assume that it's low on charge, okay? Anytime you see bubbles in a sight glass, you don't add refrigerant until you know that you have proper airflow across your evaporator coil. Proper airflow is obtained if there's no ice up situations, okay? So you can't have any iced up equipment, evaporators downstairs. It all has to be frost free and, or maybe not frost free, but it has to be clear of ice so that way it gets good airflow and good heat transfer across it. For the most part, if you have a receiver and an expansion valve, you need to have a clear sight glass. That means it's not for the most part. You need a solid column of liquid going to your expansion valve. So a sight glass is something that we use to help us to indicate proper refrigerant charge. But all that a sight glass truly means is that that point in the system, wherever the sight glass is at, you do not have a solid column of liquid. It doesn't necessarily mean that your expansion valve's not getting proper liquid. You need to be able to evaluate the system to know for sure. It's possible that someone installed the sight glass and you have a restriction before the sight glass, okay? So you need to be able to evaluate the system. Don't just assume because you see a bubbling sight glass it's low, but I will say if everything else is operating properly and the system is calling, yes, your sight glass should be clear. Now, when a headmaster first bypasses, it's going to take a few minutes for the system to stabilize out. It's going to take a few minutes for everything to calm down. So don't just assume right away. After about 5 minutes of runtime with the headmaster bypassing, sure, your sight glass should clear up. And if it doesn't, it probably indicates a low charge, okay? So hopefully that answers your question for you. My nose is starting to itch. I'm getting that nervous itch. Yeah, 480 is nothing to joke with for sure. So, clean the timeout room. Yeah? All right. Let's see what else. The best chance of surviving higher voltages. Okay, good question. All right, guys. This is going to wrap it up. I am going to go ahead and end this. I really appreciate you guys coming in here. If I didn't answer your questions, feel free to send me an email to hvacrvideos@gmail.com. I will definitely try to get to them. I really appreciate this. I will be doing this again next week. Monday, 5 p.m. Pacific time, so long as I don't get any service calls and I can make it to the stream on time. I will be at the iHacky Trade Show in Pasadena. I will probably be getting there first thing in the morning. Feel free to hit me up on all the social media sites, Instagram and Facebook. Those are the two that I'm active on. Let me know if you're going to be there. Don't hesitate to stop me if you see me, okay? I really appreciate this, and I'm going to, let me see if I missed anything here. I don't think I missed anything, so if I did, again, guys, just throw it in there, okay? Really, really appreciate it. We're going to go ahead and cue up the outro music, and I got to figure out how to, I did something weird on my thing, and I'm going to go ahead and transition that. Nope, not that. Not that. Yep, there we go. Yeah, I got to figure out this stuff. I really appreciate it, and we'll catch you guys on the next one, okay?